Good morning students. Today we will discuss about physical significance of wave function psi or importance of wave function psi, or other we can say that Born's interpretation of wave function psi. Last classes we have seen that in the Schrodinger wave equation we have seen psi. Psi is called as wave function. Psi is a function of x comma t. Psi is a function of x comma t, means position and time. If it is one dimension, it is a function of x comma t. If I take three dimensions, I can write it as psi is a function of x comma y comma z comma t. So I can write it as r. R represents three dimensions. So psi is a function of x comma t in one dimension. Psi is a function of r comma t in three dimensions. What does psi gives? So see here, the wave function psi measures the probability of finding the particle at position r in a time t. Means psi can give probability where the particle is at position r in a time t. Means, for example, here in quantum mechanics, moving particle always behaves like a wave. Means, for example, when you are moving, can I give exact position of you? No, I can give only probability. He may be there, she may be there, she may be here. So I can give the probability. So I can give, she may be in the canteen, he may be roaming somewhere. So I can give the probability. So that's why psi also gives probability of finding particle at position r in a time t. Now, wave function psi. What is wave function psi called as? It is called as probability amplitude. It is called as probability amplitude. But later they found that psi is a complex quantity. Means psi is a complex quantity. Means it contains, see here, e power ikx, how can I write? I can write it as cos kx plus I sin kx. E power ikx, I can write it as cos kx plus I sin kx. Means this is the real part and this is the imaginary part. So if any function contains real part and imaginary part, we call it as complex quantity. But what about probability? So see here, if I take probability, for example, if I take a coin, if I toss it, so what is the probability of getting head? If I take coin and if I toss it, what is the probability of getting head? Is half. Probability of getting head is half. Probability of getting tail is half. So total probability will be 1. So always probability is 1. So 1 is real or imaginary? It is the real quantity. So probability is real and positive. Always probability is real and positive. But wave function psi is complex quantity. So how psi measures probability? How psi measures probability? So psi cannot measure probability. Means wave function psi has no direct meaning. Have you understood what I said? First of all, I said that psi measures probability. But later they found that psi is a complex quantity and probability is real and positive. Means psi doesn't gives probability. Then which one gives probability? That is given by Born. So see here, hence psi cannot measure probability of finding particle at position r in a time t. Because psi is complex quantity, it cannot measure probability. So it gives the presence of particle around r comma t. Only it gives indication, means it gives the presence, that's all. It cannot give probability. So which one gives probability? That is found by Max Born. So the probability interpretation of wave function was given by Max Born in 1926. That's why we call this topic as Born interpretation of wave function psi. Okay, so according to Max Born, the probability of finding the particle at position r in a time is given by modulus of psi square. It is not given by psi. It is given by modulus of psi square. Because if I do square, I'll get positive. For this positive term, if it gets negative also, if I take modulus, it becomes positive only. So probability is real and positive. So this gives the probability. So modulus of psi square is called as probability density. Now tell me which one gives the probability, whether it is psi or modulus of psi square. So probability is given by modulus of psi square. Means probability is given by probability density, not probability amplitude. Next, how to find the probability? So the probability of finding particle in a volume element is dV. Means in a volume element, if I want to, in a small volume element, if I want to find probability, what is the, how to calculate? So probability P into dV is equal to, how to find probability? Modulus of psi square. dV is equal to modulus of psi is a function of x comma y comma z whole square. dV means volume, means 3 dimensions. dx, dy, dz. So this is how to calculate the probability. Now, what is the total probability? Means, for example, see here, if I say here, what is the total probability? For tossing a coin, the probability of getting head is half and probability of getting tail is half. So what will be the total probability? 1. Means total probability is always 1. By adding these two, I got 1. So what is the total probability? Always 1. So as the particle is moving somewhere in space, space means 3 dimensions, the probability is 1. Now, how you got 1? By adding half plus half. But if many quantities are there, what I need to do? I need to do integration. Addition of infinite number of terms is nothing but integration. So modulus of psi square dV over entire space must be unity. The total probability always it should be equal to 1. So I am taking triple integral minus infinity to infinity modulus of psi square dV, which is equal to triple integral minus infinity to infinity modulus of psi square. This is minus infinity to infinity modulus of psi square dx dy dz is equal to 1. This is called as normalization condition. This we call it as normalization condition. This is the normalization condition in 3 dimensions. Okay, if I want to write normalization condition in 1 dimension, how to write? If it is 1 dimension, I need to take only one component. So integral minus infinity to infinity modulus of psi square dx is equal to 1. This is the normalization condition in 1 dimension. Instead of dx, you can take dy, or otherwise you can take dz also. Okay. So normalization condition always shows that sum of the probabilities always will be equal to 1. So this is about the physical significance of wave function psi. So if they ask for importance of wave function psi, till here you need to write. Next, you need to know something more about wave function psi. It is not important for examination, but you should know, that's all. So limitations on wave function psi. Okay, what is the limitation on wave function psi? See here, wave function psi must be finite. Always it should be finite. It should not be infinite. It never takes infinite. That is one. Next, wave function must be single valued. Means it should have unique value. Next, wave function must be continuous. Continuous means its derivative must become continuous. Means, for example, if I take psi is equal to e power ikx. What is the differentiation of this? Dou psi by dou x is equal to e power ikx into ik. If I differentiate again, I'll get again e power ikx into ik. Means it never becomes 0. This wave function never becomes 0. Its differentiation never becomes 0. That is called as wave function continuous. Next, wave function must be well defined. Next, wave function vanishes. Wave function vanishes at boundaries. Wave function vanishes at boundaries means wave function will be 0. It will be 0 at the boundaries. So wave function must be finite, single valued, continuous, and it vanishes at boundaries. At boundaries psi becomes 0. Okay. So these things you need to remember so that for further topics it will be useful. Okay. Thank you.